Hello, everybody. We are going to be adding on to our arithmetic sequences. And so just to kind of recap what we talked about the other day, if we have a list of terms, these can be considered an arithmetic sequence if they have a common difference, or each time the number changes, it's changing by the same amount. So we're going to look at this graph to the right, and we have our first term here. So we're going to consider that x value of 1 to be our first term, so the y value is -2. Our second term, the y value is 0. The third term, our y value is 2. And our fourth term, the y value is 4. And so if we look at some sort of pattern, or look for some sort of pattern here, from -2 to 0, we are adding 2. From 0 to 2, we are also adding 2. And then from 2 to 4, we add 2. So this has a common difference, or what we use a little d for, of a +2. So each time it changes by 2. So next we are going to predict the next steps. So we ended at 4, and we're going to find the next 3 by doing the same common difference. So we are going to add 2. 4 plus 2 is 6. Add 2. 6 plus 2 is 8. And then add 2. 8 plus 2 is 10. So that's where we left off last time. So now we are going to be taking that sequence, that arithmetic sequence, and we're going to be creating our own equations. So last time we talked about equations and plugging in numbers to find the value of a term. But now we're going to be creating that sequence. So we're going to be finding the equation for how to find the next numbers in our arithmetic sequence, so that we don't have to sit here and add 2, add 2, add 2. We can plug in which value we want. So if we want to find the 10th number or the 50th number, we can just plug it into the formula. And so to do that, we are going to use the nth term of an arithmetic sequence with first term a sub 1, which is the first term. Here we go, first term. And the common difference, which is d. And so we have a sub n, which is the value of the term we want. So that's the final answer that we're looking for. And n is the number of the term. So the term number. So if it's the 5th number, the 100th number, all of that. So we are going to plug in the a sub 1 and the d to be able to write our equation. So here we have the sequence 1, 10, 19, 28. We are going to look at the common difference, how much each time the number changes. 1 to 10 is +9. 10 to 19 is +9. So our common difference, our d, is 9. And our very first number, the very first term, is 1. That is a sub 1. That's going to get plugged in here. And we'll take our 9 and plug it in for d. So when we rewrite our equation, we have a sub n. That stays the same. Our 1 was a 1 plus parentheses. N is going to stay as n minus 1, and then a d, which is 9 on the outside. From here, we are going to distribute. And so a sub n equals 1 plus, distribute. 9 times n is 9n, minus 1 times 9 is 9. Now we're going to combine our like terms. We have a +1 and a -9. We add those together, and a sub n equals 9n minus 8. So that is our equation, 9n minus 8. And then from here, the next question asks us to find the 12th term in the sequence. In order to find the 12th term, that means our n is equal to 12. So we are going to plug that into our equation. So a sub 12 is equal to 9 times 12, minus 8. 9 times 12 is 108 minus 8. Base of 12 is going to be 100. Now to find our which term, so we are trying to find n when our sequence is equal to 172. I'm going to take my formula and set it equal to 172 and solve for n. So we're going to add 8 to both sides. It gives me 180 equals 9n. Divide by 9, and n is equal to 20.